signs is according to our basic definition, that is it is complement of each other. So, we say this is a forbidden state in the case of a RS flip flop, but in case of a JK flip flop, when both inputs are high and there is a arrival of a clock pulse, the output is toggle. Toggle means it changes its state. Changes state, that is, if it is previously set, so JK flip flop will reset when both inputs are 1 and there is an arrival of a clock pulse. And if the both input remain 1 and there is a next clock pulse, and in that case again the flip flop will toggle, that will it changes its state. If it is previously set, it will become reset. If it is previously reset, now it will be set. So, this we can also see from this circuit diagram. You make both inputs at 1, clock is also 1 here. If previously q is equal to 1, in that case you will get a all ones at the lower one, and q bar, which will take this q bar as 1, that is it will be reset now. And if previously it is reset, that is q bar is equal to 1, this will cause the upper circuit to work according to the gates operation, and it will cause the q output of the flip flop as 1. So, this is the beauty of the JK flip flop. In this case, you see in the truth table, the condition both inputs J and K, one is not forbidden, but it is called as the toggling mode. This toggling mode is very important in the digital circuit applications of flip flops, like in the counters and timers. So, when both inputs of a JK flip flop are kept high and the arrival of a clock pulse, the output of the JK flip flop changes its state, and this mode is called as the toggling mode. When we want to keep a flip flop in a toggling mode, we are to make both inputs of the flip flop as 1, and there is a arrival of clock pulse, and on arrival of every clock pulse there is a toggling in the output, that is changing of the state of the output. Now, in this slide we are showing a logic symbol of the JK flip flop. We have two inputs, input J, input K. We have two outputs, output Q and output Q bar, and we have third input as clock input. A small triangle on this input shows that the edge triggering, and it is a positive edge triggered JK flip flop logic symbol. Now, as I told you in the previous slide, that JK flip flop is very working in the working of JK flip flop. When both inputs are 1, it goes into the toggling mode. Now, in digital circuits, it is required that the flip flop must toggle once in the 1 clock cycle, but sometimes there is a tendency of the flip flop that it toggle more than once in a single clock cycle. So, this problem must not be there if we want the circuits which are using JK flip flop in the toggling mode to work properly. So, this problem is called as the racing problem. Racing problem means when the flip flop toggle more than once in a single clock cycle, that it changes its states twice in a single clock cycle. So, that is called the racing problem, and that must be avoided at all times. So, to avoid this racing problem, we have a new flip flop which is called as the JK master slave flip flop. As the name implies, there are two flip flops one flip flop is called as the JK master flip flop and the other flip flop is called as the slave flip flop. Now, whatever this master JK flip flop does in the positive clock cycle, positive edge of the clock cycle, that being copied by the slave flip flop in the negative edge of the clock cycle. So, we have a master flip flop JK flip flop and a slave JK flip flop, and this combination we have used to avoid a racing problem, that is toggling of the flip flop more than once in a single clock cycle. So, we will see the circuit diagram now. We have a J input, we have a K input, both are given here, and we have a clock input. The output Q bar is given here and Q is given to the J side. We have Q and Q bar here, and you see here we have a clock signal here, and this clock signal is given to a NOT gate, and we have a clock bar signal. Now, this clock bar signal is activating the slave flip flop. So, this type of circuit is used in a JK master slave flip flop, in which actually we have two flip flops, one is master and other is slave, and whatever master does, master flip flops does, or whatever operation it performs in the positive clock cycle, the slaves copies in the negative edge of the clock cycle. So, this combination, it has seen that reduces or eliminates the racing problem in the toggling mode when the flip flop changes its state from last state in a clock cycle, and the racing problem is avoided. So, we will study here in JK master slave flip flop. To avoid racing, JK master slave flip flop is used. Toggling more than once in a single clock cycle must be avoided. So, we have now a very important flip flop, like we converted RS flip flop into the D flip flop in the applications like counters and timers. We always use a JK flip flop in the toggling mode. In toggling mode, both J and K inputs are kept high or at logic 1. So, this a flip flop designed to work only as a in the toggling mode in the applications where our function of using the flip flop is to only toggle, but not to store a data, like in the counters and timer circuits. We use T flip flop. In this T flip flop, we have a T input, and JK, J and K both are tied together and both are kept high. So, this is the logic symbol of a T flip flop. So, this ends our session on the flip flops. Thank you very much. In this, we have studied the RS flip flop using NOR gates, RS flip flop using NAND gates, D flip flops, clocked RS flip flops, JK flip flops, and JK master slave flip flop. Thank you very much.